يا أرحم الراحمين. رب اشرح لي صدري ويسر لي أمري واحلل عقدة من لساني يفقهوا قولي. الحمد لله رب العالمين.
Alhamdulillah. Thank you very much, Sai. So how is everyone? Macam mana keadaan semua orang pagi ni? Ngantuk ke? Have
Agak tidak bertenaga.
macam mana ni, kena minum Red Bull ke macam mana? Itulah pagi-pagi ni kan. Apa? Monday blues lagi. Weekend tu orang I support the proposal of having 3 days of a weekend kan. Tapi lama sangat kan. Orang lain macam mana? Zat agak tidak tenaga.
Mengantuk.
Ngantuk. Itulah kalau dalam kelas dulu kalau kita orang ngantuk we used to play tamwa. Sebab amazingly if you play tamwa with someone regardless you would actually end up segar sebab kita nak menang kan. Tapi unless kita macam buat dono lala kita itulah. So bila kat rumah susah sikit kan nak main tamwa. Tak tahu nak main dengan siapa. Boleh tanya adik ke. Alright, anyone else want to share how they feeling today? So senyap. Itulah hopefully.
Okay, Doktor.
Okay, Alhamdulillah. That's very positive of you, Amni. Okay, so thank you everyone. Again, for those who've joined on time, congratulations. InsyaAllah ada pahala menanti di situ and there's greatness and because every goodness must be repaid with goodness and. Okay, so let's start off with discussing tutorial yang sebelum ni. Again, I just want to open for volunteers lah. Kalau you guys want extra 5 marks for your carry marks. So I'll put it in your assignment 1 marks. So any takers?
Me.
Irene.
Yeah.
Orang lain ada nak? Kak Irene saja nak. Macam ni Irene je lah A+.
Nak juga, Idol.
Okay, cool. So Irene nak question mana?
Question 1.
Okay, so Irene take question 1 and then Akmal question 2. Okay ke?
Okay.
Alright, cool. So I guess I'll pass the class to you. Oh, saya lupa record. Selalu lupa. So whenever you're ready, Miss Irene, the class is yours. Okay Kak Irene.
Tengah buka dokumen.
Okay. Sure. Takut saya pula putus tiba-tiba. Okay. So this hopefully semua orang dapat buatlah kot our tutorial and we'll discuss it. So prepare questions for Miss Irene.
Hello, okay. Am I sharing?
Belum lagi. Okay.
Oh,
Yep.
okay. Can you see?
Yes, clearly.
Okay. So, tutorial 3, question 1. So the delta T min was 20 Celsius. So this is just me doing the PTA. So there's 4 streams, hot, cold, hot, cold. Okay, so this is the PTA, that's the plus deficit. And then I got Q recovery 23,600 kilowatts. And the Q was 9,200 200 kilowatts, and the QC min was 6,400 kilowatts. The T pinch was 510 Celsius, and the T pinch hot was 520. T pinch cold was 500. I think that's simple enough. And then I did the HEN. So how do I explain this? Okay, so yeah, so this is according to the table in the notes. Okay, so the table in the notes. Yeah, this one. So for the above pinch, is the number of streams for cold stream bigger than the number of hot streams? So that's a yes. And then is the CPC bigger than the CPH? So that's a no. So we split the hot stream first. So we split the hot stream. So there's only one hot stream. So we split this one. But first we count the delta H first. So there's that. And then I split it to 40 and 5 because I wanted I wanted to make the I wanted to make this one the same, which is 1000 kilowatts, and then this one is also 1000. So we can cancel that out, so we don't have to use an extra heater or something. So we're left with this one, this match. And then I counted the temperature. Just comes out to this, and then the feasibility, so it is feasible. And the heater is, yeah, and I get 9,200 kilowatts, which is the QH min. So that's for the above pinch, and then we have the below pinch. We do the thing again, which is the hot stream more than the cold stream, and then it's the same. So yes, and then is the CP hot more than the CP cold? Yes. So yes. So yes, according to the table from the notes, we just do the matches like usual. So we did the matches like usual. We get the cooler here, which is 400 kilowatts, which is yeah. Oh no, did I do something wrong? Oh wait, no, this okay. So 400 kilowatts and the 6,000 kilowatts. There's two coolers, and if we do the feasibility, it is feasible. So yeah, and then this is my final answer. So there are 7 units of heat exchanger, 1 heater, there's 2 coolers, and there's a split here on the first stream. Okay, so any questions? I think, yeah.
All right, good job, Irene. Yay, round of applause. So yeah, I think your answer is already correct there. Do we have any questions from your fellow classmates from the class to Miss Irene? I like that your work is ada nak tanya soalan. Sila. Tak ada? I like that your work is very kemas, so that's good.
Oh, okay, thank you.
Yeah, and it seems like semua dah betul sih. So the typical way to go is macam Irene sebut lah. So you have to go through the PTA first, and then after that go through that stream. Maksudnya tengok number of streams, and then you tengok the CP, and then you do the matches. So Irene sini dia buat 0.05 0.04 is it? 0.05. What's your splitting ratio?
Oh, so it was wait,
5.
above pinch. Okay, so the CP, yeah, 40 and 5. Because I wanted to make it kan this one 1000. So I wanted to make it 1000 also, like in the example too.
So that's a really good way to go about it lah. I think some of you tried doing a different splitting ratio and they didn't get the answer. So it's good to see lah macam mana if you can maximize it and actually tick both streams at once, and you can see the number of heat exchanges pun you get to minimize lah. So fantastic. I think Irene semua speechless. Bagus sangat.
Well, yeah, I had a question,
Yeah,
doctor.
sure.
So okay, so yeah, 45, right? So as you said just now, ada yang split to different they have different splits lah. So do we macam contoh if I split two different numbers and then I didn't get, so it's not guaranteed lah, as the
Yes.
teacher used to say. So I have to keep trying new
Yes.
splits. Oh,
Yes.
so if I don't get it the first time, then I have to get it the second time.
Yes. Unfortunately for this one, it's a bit tough lah. And untuk heat exchanger network, that's usually the case. So it's more of us trying and error lah. So kalau it's not feasible, then we know it's automatically wrong. Kalau dia tak feasible, janganlah kita biar our answer like that. So it means there's something wrong lah. So usually when you do it the first time, you already see lah dia punya 1000 ni. So you see, okay, boleh lah kot 5 and 40. So if that's the case, then kita boleh terus we can easily just tengok and dia akan jadi feasible lah. But if it's still not feasible, then we have to do other methods, and we'll see that I think for question number 2. Sebab question number 2 I think it's a bit difficult lah.
Yeah.
And we'll see that. Okay, so thank you for the question, Irene. Irene present, Irene tanya soalan. Anyone else want to ask question? Senang je. Boleh buat, okay? So I hope everyone got the same answer as what Irene got. So thank you very much, Irene. And I write your name here untuk you punya 5%, Irene Charlene. So congratulations, macam tu je dah dapat 5% kan. So hopefully if you still have troubles with that, you can let somebody know ataupun tanya Miss Irene and try to get that sorted lah. Untuk stream splitting, as you realize, they would not say in the question. So for me particularly, I chose this question untuk this tutorial kan. But if you see last tutorial tak ada pun stream splitting. But then in your heat exchanger network, so you would get questions and then you have to be alert lah on how to solve it. So now we have to actually start to understand lah, oh kalau macam ni apa kita nak buat, macam tu lah. Alright, so hopefully that's alright. Do you have, oh yeah, so no more questions, and then I guess I pass the floor to Akma. Okay ke Akma?
Boleh kejap
Boleh, tak ada masalah. Yang ni, I think most of you guys got the answer already for question 1. So should be okay je kot. And actually this is one of the examples in the textbook lah. So if you want to read more on that question, you can do that. Yang tak dapat, hopefully boleh try balik. Okay, so see this one.
Dah nampak ke?
Yes.
Okay, for question 2, macam biasa buat PTA analysis to determine dia punya pinch temperature and dia punya QC mean as well as the QH mean. So first thing first, kita akan determine dia punya interval temperature. For cold stream, kita akan plus T min divide by 2. For hot stream, minus T min divide by 2. Then lukis dia punya shifted interval temperature diagram. And then kira punya heat balance semua. Lepas tu buat first cascade. Cari dia punya the highest negative value. And then buat the second cascade. And the second cascade start with the highest negative value tadi tu. And then kita positifkan that value. And then kira lah sampai dapat semua value kat tepi ni. And then the highest value kat sini is QH min. Kat sini QC min. And then dapat pinch temperature dia which is 63.5 degree Celsius. Lepas tu kira dia punya tip pinch hot and tip pinch cold. Then lukis grid diagram macam biasa. Lepas tu buat above pinch and then mesh dia punya age string ikut dia punya CP value. And above pinch tak perlukan cooling utilities. So akan dapat lah kira-kira lepas tu akan dapat balik QH min 840 kilowatt, which is sama macam kita punya PTA analysis. Then buat feasible test for both heat exchanger and then buat below pinch, meshkan each string macam biasa and then kat below pinch pun tak boleh ada cooling utilities sebab QC tadi kita dapat equal to 0. And finally buat the full grid diagram yang consist of heat exchanger for both above and below pinch. Kira heat exchanger dapat 1, 2, 3, 4, 5. So total heat exchanger yang required in this question is 5 heat exchanger. That's all. Thank you.
Menariknya, semua dapat jawapan sama macam aku mah.
Lain.
Lain. Azrai dapat macam mana? Kalau yang lain?
Saya buat above pinch je.
Sebab dia threshold kan? Tapi PTA ada 2 kosong juga ke satu je?
2.
Oh, okay. That's interesting. That's something new for me. Sebab sebelum ni saya buat soalan dia T-pinch dia 6. Semua PTA dapat 0 2 tempat
Saya tak sure tahu medium jawapan.
Tak, that's fine sebab before this I put the question for 6. So yes, this is a threshold problem. Tapi what you did here betul je sebab dia jadi pseudo pinch. Sebab dia threshold problem tapi dia nampak macam pinch sebab dia ada near pinch. Tapi dia you cannot call it as a pinch lah. Tapi design awak let's see, you have 1, 2. Should be okay je betul ni. Semua feasible kan? Awak check dah kan?
Feasible.
Betul. So actually if the question becomes 6 ke 7 ke yang ni threshold problem ni dia punya delta T threshold is 7. So if you use a delta T min of 6, dia terus takkan dapat 2 kosong tu. You only get the last 0 at the bottom lah. So bila dapat last 0 kat bottom, dia akan jadi macam above pinch lah. Tapi kalau Azrai buat macam ni? Kalau above pinch?
Saya dapat 4 je unit.
4 unit. Okay. Awak nak tunjuk tak design awak? Ke macam
tak scan lagi.
Oh, tak scan. Okay. Tapi maksudnya awak apa yang beza? Dia punya hot utility ke tak ada?
Hot utility ada 1.
Okay. Alright. That's interesting. So and you've checked for the feasibility?
Feasible.
So feasible kan? Okay, then if it's feasible then should be alright lah. Just hopefully semua calculation betul lah. So yes, we can definitely get adakah macam ni design awak? Sekejap. Thank you very much Akmal. So I write your marks kat sini for 5%. Congratulations.
Thank you.
And okay, and also yang semua dapat sama macam Akmal, that's a good job juga. So that, yes, that's correct kan? Oh, saya tak masuk lagi sekejap let me join first. So for this threshold problem, for some people dia akan dapat if you change the delta T min, you realize the answer would be a bit different lah untuk the cases. So kalau you punya delta T min is 10, you can treat it macam biasa. Tapi kalau delta T min dia jadi 7 macam case PTA tu lah, you get 2 zeros kan. So you get your near pinch ataupun pseudo pinch. And if your PTA, if you use a delta T min of 6, then you realize that dia akan jadi threshold problem and you only have 1 zero lah. So yang ni saya tunjuk awak. Okay. I'll show you guys. I think siapa? Oh, tak share screen. Azri, awak dapat macam ni ke? Sekejap, share screen. Boleh nampak kan? So, did you get something like this? Ada orang dapat macam ni tak? Azrai ada ke?
Lain sikit.
Lain sikit Okay, so macam mana awak buat?
Sekejap doktor, saya scan.
Oh, okay, bagus ya. Alright. Cool. So kalau guna teknik pseudo pinch, actually if you use composite curve, kalau kita buat, you akan dapat gambar yang macam ni lah. Sebab tu susah. Sebab tu dia jadi macam pseudo pinch sebab it's like a pinch, and sebab tu you dapat at 7 degrees you get these two zeros lah. So when it's two zeros maksudnya this not actually a pinch but then it acts like a pinch. Sebab tu dia pseudo pinch kan. But it's a threshold problem, but you can treat it you can design it macam mana yang Akmal design tadi lah. So you can easily just do it above pinch and below pinch and you dapat design macam ni. So this is exactly what Akmal dapat tadi. So yes, that is correct kan. But then if you do from PTA and you use delta T min of 6, you would actually get that the QC min would become 0 kan. And then you nak buat matches sebab you nak buat dia macam above pinch. Tapi bila kita buat tak feasible. So you nampak kat sini, I do the first matches using a CP table. So CP hot, CP cold. Nampak kat sini 80 dengan 40 kan. And 36 and 40 kan. Tapi bila buat yang heat exchanger A tu dah jadi tak feasible kan. So because it's not feasible, this is another method that you can actually try for threshold problems or any cases which have hotter cold streams. Ataupun basically bila kita buat dia tak feasible lah. Kita dah cuba kan semua and it's not feasible. So this is another method that we can try. So again macam Irene tanya tadi kan. Maksudnya kita try and error kan? Yes, so this is the time where kita main try and error lah. So this method is from Dr. Siti Associate Professor Dr. Siti Shawalia Idris. She's also another lecturer teaching this course. She did her masters in pinch, so she kind of has a lot of experience on this area jugalah. So what we basically do is we akan start at the non-utility end. So we cari mana yang paling constraint. So remember kita dah buat, kita dah cuba maximize load. So kita basically dah buat CP table. Kita dah tahu, okay, we're treating this as above pinch kan. Kita buat CP table, biasanya kita akan buat match macam ni lah, A dengan B ni. And A ni tak feasible. So sebab tak feasible, then kita akan buat dekat non-utility end. So when it means by non-utility end, kita akan solve it from here lah. From your imaginary pinch. And then you match streams closest to dia punya pinch. Azri nak tunjuk
Sekejap. Saya punya yang tu tak feasible lah dok.
Oh, dia tak feasible
Selepas.
Ah.
Yang macam tu.
Oh, punya macam ni itulah. So you akan dapat something like this lah sebenarnya. So lepas tu awak teruskan design macam biasa ke macam mana?
Selepas gambar yang tu.
Itu salah satu contoh. Okay, thank you Azri for sharing. So yes, itu salah satu contoh where we can actually end up getting the heat exchanger network to be not feasible lah. So kalau macam ni jawapan kita salah tau. So sebab kita tak feasible kat sini. So when it's not feasible then automatically kita punya heat exchanger network tak boleh cannot work lah. So this is how we do it lah. Kita start at the non-utility end and then you do it as the most constraint. So kita start daripada sini. Kita akan match streams closest to the pinch. So dia akan guna the coldest hot stream and the coldest cold stream. Tu sebab dia match yang ni kan. So kita cuba maximize dulu load. So contohlah kalau dia perlukan 3600 dengan 3240. So kita pun cubalah 3240, tengok-tengok dia tak feasible juga. Delta T dia sini is 1 degree Celsius. So it's less than lah your delta T min. So because of that, kita guna temperature targeting. So temperature targeting ni is try and error lah. So kita target berapa temperature dekat sini and berapa temperature dekat sini so that we can actually find dia punya load dekat sini. Okay, so let's say kita start with X, we start with X kat sini, dia punya degrees, we start it as 80 degrees Celsius. So kalau X is 80 degrees Celsius, kita guna delta H of 1800. And then daripada 1800 is the load of your heat exchanger. We use a temperature, we get a temperature of 85. So difference dia is only 5 kan. So it's still not feasible. So kita test lagi. So kalau kita cuba X dekat 70, then Y becomes 76. Sorry, X dekat 74, then Y become 79.6, which is also not feasible kan. And then kalau yang ni 70 and 76. So this one I guna delta T min of 6 kan. So dia jadi feasible kan. So because of that, I can do matches macam ni. So you see you only get one hot utility kat situ. So after kita dah buat yang ni, kita akan buat matches macam biasalah. So B, C, D ni semua dah pakai CP rule. Because the only problem dekat sini is the first start lah. So and then after that semua feasible lah. So from this particular exercise, what I want to show you guys is that we can actually have various ways to answer it. Tapi most importantly, a method kalau yang paling penting is kita punya feasibility. So ada soalan assignment last semester, dia in fact you didn't have to use this method, tapi dia pakai try and error to get all the heat exchanges feasible. So don't be too caught up on all the rules. It's important, yes, but kalau kita dah ikut rule kan, it's also still possible untuk kita punya matches jadi tak feasible. So if that's the case, then we have to be creative lah. So this is one way lah of doing it. So ada any questions tak for this one? Ke semua macam okay?
Doktor,
Ya? Yeah?
boleh tak doktor bagi jawapan untuk question tu?
Boleh? Maksudnya yang this one is it?
Uh-uh.
Boleh. Nanti saya screenshot and I'll send it dekat dalam group insyaAllah.
Thank you, doktor.
You're welcome. Okay, any other, sebab I know it takes time to hadam jugalah. But tapi most importantly is untuk start dekat the most constrained region. So remember untuk pinch design, whatever we do, kita akan start dekat your most constrained region. So kalau most constrained, dia akan start dekat pinch kan. So because this one doesn't have a pinch if you do it sebab dia threshold kan. So kita akan start dekat dia punya non-utility end. So non-utility end tu dia jadi above pinch lah macam biasa. So any other questions for this one? Tapi itulah this question dia macam if you itulah I didn't realise if you change it to 7 you get 2 pinches, tapi you should kalau dapat 2 kosong tu and dia punya utility kosong, maksudnya it's a threshold problem, you can treat it like a pseudo pinch. So macam mana Akmal tunjuk tadi. So yeah, basically that's pusing-pusing. Okay, so basically that's it for this tutorial, and I think there's a few questions here. So let's see if we can answer them. So hopefully yang tak dapat, you guys can try it out to try to get it. Yang tak dapat, ada yang kata you need more exercises on threshold. So threshold ni I nak kata it's quite hard, sampai ramai orang memang kalau dibuat pun it takes time lah. So kadang-kadang kita buat tak dapat kan. So bila dia tak feasible tu dia memang a bit frustrating, but just don't give up lah. So Alif, do we have to ignore below pinch since the pinch point for question 2 is 63.5 Celsius even though we have streams that have lower temperature than pinch's temperature? Ini tak faham soalan ni macam ni? Ke dah terjawab?
Doktor dah jawab tadi.
Okay, dah jawab Ni apa maksud soalan awak?
Sebab ingatkan tak perlu tengok pasal below pinch.
Sebab dia adalah threshold problem. Okay, faham? Okay, that's a good question. I'm not sure if I have to split hot stream at below pinch question 2, as the CP hot is already lower than CP cold, but I'll keep trying. So kalau you try buat, adik nak cakap ke?
Oh tak doktor, yang tu saya tersalah tengok soalan.
Okay. Alright.
Mute.
Itulah saya pun muskil apa maksud dia. Okay, cool. So that one should be alright. Okay. Anyone else for threshold problem? QC or QH is equal to 0. Do we have a minimum value for delta T min in differentiating whether the problem should be treated as a pinch problem or threshold problem? So I really like this question sebab technically when we do this threshold problem, macam soalan ni particularly, it's a bit complicated sebab kita macam, aku nak treat it as a pinch ke, aku nak treat it as a threshold problem kan. So in terms of is there a minimum value, there actually isn't one, but if you can see, macam last week punya lecture, we saw there was a low delta T min punya threshold, delta threshold, and a high delta T punya threshold. So let's see. So basically bila ada high dengan low tu, it would actually change. Sekejap, nak tunjuk. So it will actually change how we actually design it. 4, 5. So kalau kita tengok kat sini, so you have two different cases kan. So this one is a low delta T min threshold. So what occurs for this question is actually it's a low threshold delta T min. Sebab the delta T min is actually 7. It's 7 lah when dia akan ada dua zero value kan. So when it goes above 7, when you get it at 10, dia akan end up you have both utilities. So you can treat solve it macam biasa kan. But then bila kita buat, you could actually realize that it's a threshold problem lah. Tapi kalau big threshold problem, high threshold problem, macam mana pun kita buat, kita akan end up having it to only be solved by one way lah. So kita takkan ada pseudo pinch tu. So yes, there are these basically different types of it. Being aware of the type is also very helpful lah kot untuk kita tahu macam mana kita nak solve. But unless the question states that to use threshold problem ataupun for a specific way, I don't think you'll be penalized if you use pinch solving. So macam tadi kan, kita solve macam pinch pun should be tak ada masalah. So should be sama je. I didn't draw the graph of feasibility and just calculate the temperature. It will affect the marks on the test or not. So yes, if you don't draw the feasibility and just calculate, so basically if it's feasible then it's fine lah. If you can some way, if you contoh sebab ada some people they like to prove that you can basically get the feasibility just by looking at the temperatures and so technically that is correct pun. So but some people dia tak boleh nampak kan benda tu. Contohnya macam ni kan. So kalau dia tengok kat sini, I don't advise it because it might get confusing at some point. So contohnya kat sini kan, dia ambil temperature. So dia ambil temperature ni dengan temperature ni kan. So basically you're already doing the feasibility test lah. So bila kita compare ni, you already know it's feasible. So yes, you can actually say it without doing the graph. Zawil. So you can say it without doing the graph, but then basically it would be a lot easier if you show it lah to prove it. So if the question memang particularly minta for feasibility, you have to write it because there will be marks on it. Kalau tak ada, maka dia jadi kita akan deduct markah lah kat situ. Okay, so that's all for our second tutorial. Our third tutorial. Do you have any other questions from anyone before kita move on to lecture kita? Sila abaikan background music. Any questions? No? So semua happy eh? I wanted to say something. So far okay. Oh, ada yang remind, and I thank you very much, Sue. I like that you always remind me to drink water. Yes, Sue. So Haila, you want to ask a question?
Oh, that's me. I remind you to drink water.
I know. I always read it because sebelum ni pun you always remind me. I'm like, oh, every time you say that, I terus nak get a glass of water.
Yeah, it's a good thing.
Yeah.
Doctor,
Ya.
Kan yang kalau macam cara doktor buat tu kan doktor set X tu doktor start 80 degree Celsius kan. Macam try and error method tu, like how kita nak macam target temperature mana yang kita nak start dulu. Like is there a trick to it?
To be honest, if you ask me, I would say no. But then, kalau kita bijak kan, one of the ways yang kita boleh buat is kita akan tengok kita punya streams lah. So because if you can see here, soalan ni is, I think there's another question which is, but that's a really good question. Is there a way to end? There's a tutorial question from another lecturer yang dia orang buat for class. Dia macam target based on what they think is feasible lah. So the idea is to make sure that your hot stream is always hotter than your cold stream. Macam tu lah. So the reason why I did this start dekat 80 is bila dekat sini tak feasible kan. Okay, so bila benda ni tak feasible, I know that we know that if it's 121 degrees, so sekarang ni if it's 121 degrees, dia tak feasible sebab dia maximize your load. So you can either do either ways lah sebenarnya. You can either target from your delta H ataupun target from your temperature. So contoh kan, kalau kat sini kita buat it's 3240 kan. So okay lah, it's not feasible kan sebab delta T dia is only 1 kan. So we can straight away target kat sini contohnya 1500. So if you do that, you can straight away guna temperature. Check the temperature and see if it's okay. But you do the same thing lah. So kita akan test untuk X and Y value ni lah. So it's not really a way, it's not, there's no particular rule of thumb lah, but we can always guess, do an educated guess lah, I would say. So why I chose 80 is basically sebab when I was looking at this temperature lah, sebab dia 100, 120, difference dia 1 kan. So I'm thinking, okay, kalau 100 is still tak cukup kot. So I started at 80. Contoh kan. So you can start, ada certain people dia lucky enough to start at 70 kan. So no, there isn't a particular rule of thumb, but we can always make macam tu lah an educated guess. But yes, threshold problem dia memang take up quite some time lah kot untuk kita buat. So I hope that sort of answers your questions. Syahila?
Yeah, thank you.
Okay, cool. And if anyone's keen, I can get the question, satu lagi question yang agak susah, and it's a threshold problem juga. And probably you guys can try it out if you want. I'll just post it in the group lah, in the WhatsApp group lah kot, if you guys are keen to try it out and then see if you can get the answer lah. Tu just add on lah kot kalau siapa nak try. So you can try to do it. That one's also a tricky one lah. So that one you also have to use macam ni lah, something like this. Tapi certain people dia ada orang dia end up splitting it. So you can get a variety of design lah. But I'll just put it up for you guys so if you want to do the extra practice lah. Okay, so if that's all, is everyone happy for us to continue to our lectures?
Yes.
Okay, cool. So tak ada yang nak break ke apa? Semua okay ke?
Okay.
Alright, fantastic. So alhamdulillah, I'm happy that everyone's tried the questions. I think the new era is a lot of students dia suka cari cara lain untuk study and I understand that since our pandemic, a lot of people have been turning to chat, CHEGG, and a lot of people have been uploading questions there. Please do know that your lecturers do know if you end up posting things there. I guess it's because it's a tutorial question, I don't really mind. I don't think lecturers really mind because it's a way that you guys can study. But if it's assignments ke, task ke, please refrain from doing it because it would macam rugilah kat you guys, and at the same time we don't really know macam mana kita nak properly learn it lah. So God knows kan what is everyone's doing kan. I don't know siapa buat, tak ada orang akan tahu pun siapa buat, tapi at the end of the day macam mana, it's our own honesty lah. Kalau kita dapat markah tinggi kan, would it be a blessed punya markah kan? Ataupun nanti kan kita macam markah tinggi and then suddenly bila kita kerja pun jadi susah kan. I dulu tak suka lah kalau macam lecturers ke cakap-cakap macam ni macam oh okay, because we're all very big already kan. So I trust you guys and I know semua boleh fikir dengan jelas lah. So hopefully please don't do it for your tests, your exams or for your assignments, because those things ada markahan. For tutorial, okay lah, there's no marks in it. But if you have any questions ke apa, feel free to nak discuss ke with friends. That is one of the good way lah untuk learn sebenarnya, rather than asking for the answers online lah, which I think kalau macam tu kita tak dapat belajar lah. We rarely get to use the opportunity to learn properly. And so that's just a reminder for everyone, including because I think some people I think previous semesters adalah macam some lecturers they weren't happy with it and sampai diorang tak berkat and end up ramailah student yang fail because of that. I never pray for my students to fail, but then we don't know kan, kalau assignment ke test ke exams, we play with a lot of other lecturers as well. So macam try to be honest with yourself. And okay, so that's just a big reminder. So today we're actually going to start with our new chapter, so chapter 4. We've already covered these few bits here. So if you realize sampai sekarang we've already done energy targets. I think semua dah okay kot, dah done quite a lot of practice. Your PTA, your CC, maybe your composite curve ada tak ramai sangat yang buat kan. But then if you've done it, that's good. We're going to look at that tomorrow more in our second part of chapter 4. So next week lah. Your heat exchanger network, kita tengok macam nak design. So in exams ke test ke, they won't be macam part 1, part 2 and they wouldn't give us purposely question yang tak ada stream splitting ke apa. So it has to be our creativity lah to see how to answer that. So be out of the box thinkers lah. So now we actually want to see how we want to optimize dia punya heat exchanger network, and kita cuba consider cost pula. So we're going to see what actually contributes to our total cost and how we want to optimize it. So basically we want to see lah apa the difference between capital cost and energy cost, and see how we want to minimize number of HE units using loop breaking and path relaxation. So loop and path ni is also something yang very useful lah for this particular course. So when we're talking about capital energy, nama pun capital, so it's a capital cost that we require. So macam kalau dia macam the first, so if the basic way to translate that is the first amount of money sum yang kita bayar untuk start up kita punya plan, and so that's your capital the capital cost. So when we actually looking at recovery of heat daripada waste steam, kita ada trade off between reduced energy cost and increased capital cost. So basically if the more we reduce your energy cost, the higher your capital cost would be. So basically your correct setting for your delta T min is economical. It depends, your energy cost is a function of delta T min. So if you tengok kat sini, you can always say, oh kalau macam ni, macam sebelum ni kita nampak kan, we always want a smaller delta T min kan. So kita punya, sorry, this is not delta T min. I should have put gambar delta T min. So gambar delta T min dia macam ni, baru perasan. So delta T min, ini cost kan. So kalau should be macam ni kot gambar dia. So this is your energy cost. And I think you've seen this before in our previous lecture notes. Even in your textbook. So this is your capital cost. So if you punya delta T min is smaller, you see that your energy cost would become smaller lah. So if you increase your delta T min, your energy cost will also increase. For your capital cost, it's the other way around. So kalau kita punya delta T min is smaller, it would require a bigger capital cost sebab you need equipment which is specialized to take this very small delta T min. So it's a bit hard for the system to take. So sebab tu kita akan ada satu lagi line kat sini, and I don't know how. So it's a total cost. So what we want to consider is your total cost. So we want to cari mana satu line yang paling sikit untuk your cost as a whole. So kalau kita tengok kat sini, so this is looking at your heat recovered. So the more your heat recovered, you can see your capital cost will start to increase kan. But then your energy cost will decrease. So what it means by capital cost macam tadi lah, the equipment we want to set up kan. Tapi energy cost ni is macam kita punya QH min, QC min. And kita punya utilities that require to pay monthly. So when our energy cost, when we recover more heat, kita akan dapat we have less utilities that we require from external sources. So that's why you have to find the trade-off between capital cost and energy cost. So it's just two different ways of drawing it lah. So this is delta T min, yang ni heat recovered kan. So bila kita dapat kat situ, kita akan cari the lowest point of this graph. And I think soalan exam last semester kot ramai orang yang got confused with this particular graph lah. So kadang-kadang dia tak bagi yang delta T min berapa. So we have to find dia punya delta T min yang sesuai kan with our particular system. So this picture is basically saying lah kalau heat recovery, so if your heat recovery is increased, so dia punya Q recovery kat sini increase, it decreases your delta T min lah. And basically when your heat recovery increases, that's why you get lower energy cost, but then it increases your capital cost. So sebenarnya it's in a way we have to be wary that semua tu interrelated. So kalau delta T min tu we cannot just easily say or assume it's 10 kan, unless dia memang specified in the question. So kalau assignment, contoh macam assignment tu ke apa kan, if you have a plan, you cannot you have to try to test several values of delta T min and see how it affects the total cost, not just the energy cost. So when we're talking about QC min, QH min, it's only the energy cost. Okay, so everyone okay until there? Faham ke? Kalau tak faham boleh cakap. Yes, no? Adakah senyap?
Okay.
Okay. Alright, cool. So alhamdulillah. So basically that is kita punya trade-off lah. So for kita punya capital cost, there's a lot of things that actually affects the capital cost. Amongst it is these 6 things lah. So first things first is dia punya number of units. So number of units is when we're talking about your heat exchanger units lah. So it's like for example kalau kita ada berapa banyak number of units that we calculate. So remember kalau if we perasan we always try to minimize it and so when it's more you will increase your cost, but you need more equipment to introduce heat exchangers lah. So obviously if that's still not clear, 9HE is more expensive than 5HE, contoh dia. So we will always want the less number of units. Kalau number of shells ni macam shell and tube lah. So it's basically again talking about the equipment. So talking about the heat exchanger itself. Materials of construction is the type of material that we use. Either it's stainless steel ke, copper ke, iron ke. It depends on what end. And I think this one you've looked at another cost dalam a different cost and materials of design design materials, something like that. So but that's not covered in this course lah. But then if you want to read more about it, you can read kita punya textbook Robin Smith tu, because dalam tu dia memang cerita lah pasal semua. Equipment type, so what type of equipment that we actually use for our system. So this will all contribute to the capital cost, and we're talking about other than heat exchangers lah. Or pressure rating, so again this one's apart from your heat exchangers, so higher pressure rating would introduce. So this is when we're talking about steam and so it would introduce a higher cost. And lastly the area, so area ni is area of your heat exchanger. So if your area is bigger, it would require more cost, more money lah. So this one kita akan tengok in part 2. So what we're going to cover for this particular course is number of units dengan area. So the rest of it you're going to study either, if not in other courses, it'll be, you can also read on it in the textbook. So yang dua ni saja kita akan tengok. So this is going to be our part 1 and this is going to be our part 2. Okay, so that we're going to cover that next week. Okay, so we're going to start into part 1. Semua okay lagi ke to proceed, or would you like to take a break or something?
May is fine.
Okay, that's good. Thank you for the response. Take 5. Okay, cool. So thank you for the response and thank you juga. So probably we'll take 5 and we start balik at 9:05. Okay ke?
Alright, Doctor.
Okay, so bolehlah buat Milo ke apa yang bagi tenaga sikit. Buat kopi ke. I'll see you guys back soon. Sorry to ni pula. Semua okay ke untuk kita proceed? How is everyone?
Okay, Doktor.
Cool, fantastic. Alright. Alhamdulillah. Hopefully we've got a few breathers as well as some more oxygen. Orang so kata kalau dalam air kita ada oxygen kan. So if you feel ngantuk ke apa kan, kalau kita minum air kita akan jadi segar semula. So hopefully everyone's okay untuk kita proceed. So as I mentioned before, we basically have two different parts untuk capital cost. And we're going to just, for today, we're just going to look at how to minimize kita punya number of heat exchanger units. So remember, the idea kat sini is we're playing with cost lah. Kita nak jimatkan cost juga. So ada juga yang a few people ask me regarding kenapa sebenarnya untuk splitting dia confuse kan. Kenapa sebenarnya kita tak nak letak hot utility above pinch and cold utility below pinch kan. Cold utility above pinch kan. So basically benda tu bukanlah equipment kita akan rosak ke apa, it's more about cost lah. Benda tu akan jadi pembaziran kan. So when it becomes pembaziran, kita akan rugilah kat situ. So kita nak jadi engineer pun kita kena jadi engineer yang bijak dan jimat cermat kan. Barulah kita punya company boleh excel. So if not, nanti kita akan rugi a lot kan in terms of kita punya cost spent. So nanti kita tak dapat return, so it'll be a waste lah. And this is also something that we'll see more in your design project later. So kalau kita nak buat design project kita akan tengok kan dia punya return of investment semua. So whether or not it would be feasible lah untuk kita buat. Kalau dia tak ada untung, kita tak patut buat lah. So that is how things should be kan. So these are the steps untuk kita buat loop breaking and path relaxation. So in a way, this is steps untuk kita reduce number of heat exchanger unit. So kalau kita perasan kat sini, extract and complete stream data. So this is what we've already done in chapter 1 and chapter 2. Chapter 1, sorry. And chapter 2 is kita use CC and PTA untuk dapat energy target. So this one semua dah pro lah kot And then kita design kita punya heat exchanger network. So this is the entire of chapter 3 lah. So it doesn't matter if it's a threshold problem ke, if it's stream splitting ke, apa-apa pun, kita dah ada di heat exchanger network. So we are going to look at steps 4 to 9 today. So kita ada perkataan loop ni kan, loop lah, path lah kan, apa benda dia kan. So we first want to see what does loop and path actually mean. So loop, nama pun loop kan. So loop is basically a circular path that exists among heat exchangers. So dia adalah loop untuk heat exchanger tu sendiri. Sebab apa? This is the aim kan, untuk enable heat load shift. So we want to make sure that you can actually shift the loads from one heat exchanger to another. That's how kita boleh reduce our heat exchanger punya units. So basically it's a set of connections that can be traced through a network that starts at one exchanger and returns to the same exchanger. And we'll see this together lah. So they start dekat yang they start and return at the same heat exchanger. And usually it will pass through the pinch. So from this loop, kita akan remove the smallest heat exchanger. So this is an example of your loop lah. So you perasan kat sini, dia start dekat B, goes across the pinch to to E, and then dia lalu balik dekat E ni, lalu dekat heat exchanger E ni, and then dia akan go to above the pinch, cross the pinch again, go back to B, and that is your loop. Okay. So when we have this loop, kita boleh shift this amount of energy. So we can plus minus U. So the amount of energy that requires dekat sini, kita boleh shift pergi sini. That's why you can remove one heat exchanger. So sebab tu dia kata you can transfer or you can shift loads along the loop. So contohnya kalau this heat exchanger tadi is 600 kilowatt, kan? So we can minus 600 kilowatt kat sini. So kita akan plus 600 kilowatt dekat sini. So basically kita ada dia punya heat exchanger yang cover dia punya loads yang ada. Okay. So that is one loop, but the loop doesn't tak semestinya akan one macam mana square saja kan. So it can also look like this. So see how it goes from B to D and goes to D and then pergi ke C. Lepas dia pergi C dia pergi A pula. Lepas dia pergi A dia pergi B. So it doesn't matter how it looks like, but what's important is that it starts and ends at the same heat exchanger. Okay? So make sure that dia lalu heat exchanger saja. So some people nanti dia lalu stream splitting, kalau dia contoh kan, ni boleh kan, tapi dia tak boleh tau kalau tiba-tiba kat sini. Lepas tu dia nak pergi kat E, lepas tu nak pergi kat B. Tu tak boleh sebab this is not a heat exchanger. So this one I thought it was obvious kan, tapi some people dia buat juga kan. So ni tak boleh sebab you must selalu dia punya heat exchanger. It's like you're trying to cut the path in between kan. So you cannot simply just take the you cannot simply just take in the middle of the heat exchanger. So it must be daripada end to the end kan. Okay. So that is your loop. Ada any question tak untuk loop?
Doktor, untuk yang negatif positif tu dia bergantung kat direction ke ataupun ada properties lain?
Very good question. Bagus Zach ni. So thinking in advance kan. So it will alternate actually. So dia akan plus minus. So dia ikut benda ni lah. So contoh yang kita gerak kat sini kan. So yang ni plus, yang ni minus. Okay. So kalau yang ni plus, ni minus, dia lalu sini, dia jadi plus balik. Okay. And then dia lalu sini, dia jadi minus. And dia patah balik sini.
Maksudnya alternate untuk setiap heat exchanger yang sama tu lah kan?
Betul.
Okay,
So it will alternate untuk setiap heat exchanger. So sorry iklan pula. So yes, dia akan alternate untuk setiap heat exchanger tu. So kalau the heat what we would minus is usually the smallest heat exchanger lah. So we would actually minus the smallest heat exchanger first. So itu kita akan start minus dekat situ lah. So where to start? And after that dia akan alternate lah. Plus minus. And we'll see that in the example kejap lagi. So good question Zat. Ada question lain? Tak ada? Semua happy? So loop ni just be reminded that it can come in any form lah. Tak semestinya macam ni tadi kan, satu saja, tak kan. You can also become like this juga. So it depends. Some people dia nampak yang direct, ada yang dia nampak yang macam tu. So it should give you the same answer lah at the end, and it should still be correct kan. So that is your loop. Kalau path pula, kalau loop dia bulat kan, bukan bulat, dia maksudnya must start and return at the same heat exchanger. Kalau path, it connects a heat exchanger between two utilities. So daripada one utility to the next utility. And again, you can shift your loads along the path. So another way to describe these two utilities is basically a connection between your heater and cooler. So daripada heater pergi cooler. And usually what we use for our path is to correct our T-min violation. So maybe tak clear sangat nampak ni, tapi we're going to see that kejap lagi in an example. So this is an example of your path lah, ataupun dipanggil utility path. So it starts at your heater, goes through your heat exchanger A, sampai pergi ke cooler balik. Okay. So along your utility path, again you can shift your punya load. So plus minus, sebab dia lalu sini, and then plus. So perasan dia tak lalu B, dia tak lalu C, dia tak lalu D, dia tak lalu E. So tak ada any changes on that. But your path can also look different ways juga kan. So you can also become contohlah kalau ada orang dia macam, boleh tak doktor saya nak buat macam ni kan. So contoh, okay, let's take a different colour je lah. So instead of yang ada ni, dia nak buat macam ni. Oh tak boleh. Tapi kalau ada, oh sorry bukan ni. So kalau dia tiba-tiba dia tak nak buat macam ni kan, but then dia nak buat macam ni. Macam ni. Macam tu. Boleh, tak ada masalah. Okay. So this line merah ni pun boleh jugalah sebab dia consider path daripada one utility to the next utility. So it doesn't matter what happens in between. Tapi kalau case macam ni, dia akan jadi macam ni lah. So dia akan jadi plus kat sini. Yang ni akan jadi minus, yang ni akan jadi plus, yang ni akan jadi minus, yang ni akan jadi plus. So dia akan banyak kerja sikit lah. Because you're going to have to change a lot of heat exchanger. Tapi it's also possible. So there's various ways lah for kita punya path to occur. Saya ingat saya dah letak contoh path kat sini. Tak ada. Tapi macam itulah. So that is an example of your path. Any questions untuk path? No?
Ada.
Okay, thank you for the response, Zat. Okay, cool. Itu contoh path and I think dalam textbook pun dia ada tunjuk a few other contoh lah yang you can use. I can't see any particular path at this stage. Oh, kalau nak buat macam ni pun boleh. Macam ni pun boleh. So as long as dia akan lalu heat exchanger, so this one you also get lah plus, minus, plus, minus, plus. So it doesn't really matter lah. Cuma you cannot lalu dekat tengah-tengah heat exchanger. Ini tak boleh lah. This is wrong. Okay. So that is basically kita punya loop and path. Okay. So we're going to look at this example together and try to simplify it. So dia punya question dia kata simplify the structure by reducing the number of units. So basically kita akan guna loop and path untuk reduce kita punya heat exchanger punya units number kan. So if you realize this is the same question that we've been looking at since chapter 2 lah. So dia adalah soalan yang sama yang kita buat guna CC, guna PTA and kita guna heat exchanger network. So you can tengok balik lecture note chapter 3 part 1 dan ke part 3. So this is the heat exchanger network yang kita design. So sekarang ni kita nak cuba apply loop and path. So kalau kita tengok steps ni, this one semua kita dah buat. We've already extract the stream data, we've already used CC and PTA to get the T-pinch and energy targets. We've already designed your heat exchanger network for maximum recovery. And then baru kita boleh buat loop and path. Okay, sorry distraction. Okay, first things first, kita akan find the loop untuk buat dia punya heat load shift. So daripada gambar ni mana loop? Oh sorry, saya patut tulis A, B, C, D, E. Mana loop? Daripada heat exchanger mana nak ke heat exchanger mana? Ada orang tak ni?
Sekejap doktor tengah proses.
Oh okay, sure. Sila. A, E, cepat ni. B, C, A, boleh? Boleh? Okay, so that's one loop. Ada orang nampak loop lain tak? Thank you Akasha. Tak ada? So kalau saya nampak loop ni B dengan E. So it doesn't matter lah mana-mana loop yang ada. First thing is kita akan find dia punya loop. So bila kita find loop, kita akan if kita ikut yang Akasha punya, kita akan tengok dia punya load sekat sini lah. So daripada heat exchanger, daripada kita punya loop, we're gonna look at dia punya heat exchanger. So we find the smallest HE in the loop. So kalau untuk yang contoh ini, kalau dia pakai B to E, your smallest one is this one or this one? 600 E kan? So kita akan guna yang ni untuk eliminate. So when you say eliminate, yang ni kita akan minus. So you can minus 650 kilowatt and this one akan plus 650 kilowatt. Okay. Kalau yang macam Akasha sebut tadi, antara semua ni, mana yang paling kecil? E juga kan? So you get similar lah. So ni akan tolak 650. So dia akan lalu line ni. So yang ni akan plus 650. And ni akan tolak 650. And then this one akan plus 650. Okay. So it doesn't matter what the loop is. Tapi yang penting macam ni kita buat loop tu. So dia plus minus until you can remove it. So bila kita buat minus 650, I can then remove this heat exchanger, betul tak? So dia jadi kosong kan. Okay. So bila saya remove, dia akan hilang. So ni tadi E kan. So E dah tak ada. Okay. So dia dah kurang dah. So idea dia kita nak kurangkan dia punya heat exchanger units. So daripada situ, what happens to our temperature? Adakah temperature kita sama? Ada tak temperature kita yang berubah?
Ada.
Temperature mana yang berubah? So ni dah perubahan value dia tadi. So saya buat contoh loop yang ni tau sebab dah tunjuk. So basically 800 plus 650. So dia jadi 1650. So Temperature mana yang berubah? T berapa? Another way to look at it is find the delta T in the loop. Nazifah nak jawab ke? Tak.
T3 ke doktor?
T3, okay. T3 lagi? Betul? So ni berubahan sebab load dekat sini berubahan. Apa lagi yang berubah?
T4.
T4 berubah ke? Kita kacau ke
T2.
T4?
Lalu. Oh, sorry.
T2. Banyak
T1
betul jawapan. Okay, so jawapan dia T1 kan. So kita tengok dekat sini. Mana yang kita lalulah. So sebab tu dia kata in the loop. So it's this one and this one lah sebenarnya yang berubah. Nampak ke? Tiba semua T keluar. Okay, cool kan. So basically apa yang berlaku is kita dah buang heat exchanger ni. So this temperature would change and this temperature would also change sebab heat exchanger ni dah naik size dia kan. So it becomes 1450 kan. So basically T1 and T3 would change kan. And boleh tak kita calculate berapa T1 and T3 ni? So kita guna equation mana? Kita dah lupa dah. Betul. So delta H equals to CP delta T kan. So kalau kita calculate untuk T1, macam mana kita nak calculate? So we can either use B ataupun this one kan. So kalau kita nak mudahkan hidup kita, kita pakailah cooler ni kan. So it becomes 1000. So sama je macam kita calculate temperature sebelum ni. Equals to CP dia is 15. That's why it's always important to keep the CP next to the line lah. Supaya kalau kita buat next step, kita boleh cari je balik. So T1 minus 40. So T1 kita jadi 106.7. Thank you Akasha. So sebenarnya dia sama je lah dengan temperature ni kan. So actually if you realise it, you can easily just take back that temperature lah. So ambil je balik temperature ni kan. So dia jadi 106.7. So that temperature is now here. So what about T2, T3? So T3 kita akan pakai heat exchanger. So you can either use this heat exchanger ataupun this heat exchanger. So let's say I want to use D to make it easy. So 1750 equals to 20 T3 minus 20 kan. Ataupun you can also use 1450 equals to 20 180 minus T3. So T3 dapat apa? 107.5 kan. So T3 ni jadi 107.5. Okay. So kalau kita tengok roughly at this temperature, boleh tak kalau kita tengok roughly, this is our hot temperature, this is our cool. Roughly kita tengok dia akan ada some violation, betul tak? So kalau kita tengok this value, roughly kita tengok pun kita tahu there's something wrong kan. So kalau kita check feasibility, so kita akan check feasibility of, so we want to check feasibility of let's say heat exchanger B lah, senang kan. Sebab heat exchanger B lalu dua-dua ni. So kita dapat TH diagram. Okay. So from 203.3 pergi 180, 107.5 and 106.7. So heat exchanger B is 1450 lah. Okay. So basically daripada 203.3 pergi ke 106. And then kita buat daripada 107.5 pergi ke 180. So is exchange be feasible?
No.
No kan? So dia jadi tak feasible kan? So because it's not feasible, that's why we do our path. So basically kita cari path ni untuk kita betulkan balik this delta T mean violation. So kita nak make sure kita punya graph ni bukaan. So kalau nak to make it feasible, macam ni kita nak buat B ni feasible. How do we make it feasible? Kita kena buka lah kan yang ni. Betul tak? Dia kena jadi macam ni kan? Or, sorry, salah pula lukis. Betul tak? So, what temperature do we have to change? Ke semua tak faham? Kalau tak faham bagi tahu tau.
Tak faham Doktor.
Okay, thank you. Kurang faham. Okay, that's okay. So, sekarang ni our heat exchanger tak feasible, betul tak? Sebab dia cross dekat sini, kan? So macam mana kita nak buat B ni feasible is that kita kena buka sini, kan? Kita kena buka graph dia so that kita punya temperature ni kita jadi macam ni lah. So that sini distance dia delta T min and sini distance dia so bigger than delta T min. Bigger than or equals to delta T min, betul tak? So, betul kan? Okay. So, kalau saya naikkan graph ni, so temperature yang ni lah kan saya kena ubah, betul tak? Untuk saya naikkan graph ni. Betul kan? So basically what we're going to do is kita nak value yang ni jadi minimum of, berapa minimum dia? Untuk dia jadi feasible. So delta T min is 10 for this question. Baguslah Akasha. Macam mana awak dapat 117? Daripada sini kan. So you take this value. So 107.5 plus 10. So you will get 117 dekat sini. Your graph akan buka. Nampak tak? Okay. Kau tak nampak? Kau tak nampak bagi tahu.
Faham Doktor.
Faham Okay, cool. So apa yang kita nak buat dengan path, so I want to tell you guys that supaya kita boleh nampak kenapa kita buat path ni sebenarnya. Sebab biasa orang tak nampak, kita main buat je path, lepas tak tahu pun apa yang berlaku. So sekarang ni kita nak betulkan benda ni, so kita kena cari path yang lalu sini lah. So basically kita nak gabungkan dia punya hot and cold punya utility. So ada orang boleh jumpa tak path daripada gambar ni? HA sinilah kan? Betul tak? Kan? Okay. So kalau you nak lalu sini, pergi sini macam ni pun boleh juga. So it doesn't matter lah. So it depends on whichever path yang kita ada. So what we're gonna do is that kita akan shift dia punya heat load. So let's use this first one just now kan. So kalau kita guna yang ni, kita akan, kita nak cari, kita nak shift dia punya load. So yang ni akan plus minus plus kan. Okay. So what plus minus apa? So dia akan jadi plus minus either x lah, plus minus x. So macam ni kita nak cari value x ni, kita kena remember this temperature must be minimum at least 100, berapa? 1. So it must be minimum 107.5 plus 10 kan, plus your delta T min. So 117.5 kan. So basically kita akan back calculate. So basically kita tahu value ni kena jadi 117.5. So kalau ini adalah plus x minus x plus x, boleh tak kita cari x?
Boleh.
Guna equation apa?
CP delta T.
Okay, so apa dia punya delta H? Yes. Fantastic kan. So basically it's 1000 plus x equals to your CP which is 15. And your delta T which sekarang ni kita dah cakap it must be 117.5 minus 40. So kita dapat x kita. So berapa x kita? 162.5. So apa yang kita buat is that we'll put this value in here. So ni adalah kilowatt Dah masukkan dekat sini and masukkan dekat sini. So bila kita masukkan, kita akan dapat jawapan dia kat sini. So these values dah berubah lah according to what you've already got. So you finalize the heat load and the number of units. Okay, sampai sini boleh faham?
Faham.
Faham Kalau ada yang tak faham bagi tahu. Kalau nak tanya ke, ada questions tak? Before kita proceed. Tak ada Senyap tanda faham. So basically bila kita dah habis macam tu, adakah maksud jawapan kita dah settle? So the answer is no kan. We always have to check kalau dia ada any other loop. So we always check for more loops. Kita tengok-tengok, alamak. Ada lagi satu loop kat sini. Contohnya kat sini kan. So when you get this loop, when there's more loops, that means there's more opportunities for us to reduce our number of heat exchangers. So bila kita buat macam ni, kita repeat balik step daripada awal. So kalau yang ni kita nak remove heat exchanger mana? Which is the smallest? A kan? Sebab dia 537.5. So kita akan minus 537.5. Ni plus, ni minus, ni plus. Okay, so ikut je line ni tadi. Okay. And then dah habis dia punya loop, we check dia punya so we eliminate dia punya smallest heat exchanger. So kita akan eliminate yang ni. So dia akan jadi macam ni. Okay, so remember when we eliminate dia akan jadi minus plus lah. So value kat sini nampaklah dia berubah. Okay. So lepas value tu dah berubah, kita boleh now check kita punya delta T min violation. So sekarang ni temperature mana yang berubah? Oh sorry, saya tak buat pula T1, T2. So T1, T2, T3, T4. Yang berubah? Betul ke berubah? Mana loop dia? So in the loop. Ni in the loop. Okay lah, senang lah. Kalau kita tengok yang ni. Yes, that's correct. So T2 dengan T3 kita akan berubah. So kalau T4 kita should be, kalau kita tengok kita memang tak boleh ubah lah sebab T4 ni is actually your supply temperature sebab dia cold stream kan. So dia tak boleh ubah. So it's your supply temperature. I understand T1 ni sebenarnya dia akan ubah je lah sebab dia punya load ni dah jadi lain kan. So technically T1, T2, T3 lah. Tapi basically T2 and T3 is in the loop lah. So kita akan check dia punya feasibility. So the reason why, so basically kita just calculate you punya temperature kat sini. T2 and T3 ni. So basically kalau yang T1 ni dia even though the temperature is gonna change, it should still be feasible lah. Sebab we're just looking at this temperature kat sini. Tapi T2 and T3 ni is what we have to check lah. So kita akan check dekat sini. So basically kita check how we find the T is kita akan calculate macam biasalah. So delta H equals to CP delta T. So if T2 and T3. So kita akan guna your D lah. So 1212.5 equals to 25 T2 minus 80. So that is your T2. And then your T3 would be 1212.5 equals to 20 T3 minus 20. So berapa T2 kita?
128.5.
128.5 and T3 kita? .6. So bila kita buat, kita dapat this value. So basically kita check balik feasibility. So if we check feasibility of D, you basically have 128.5, 80.625, 80, and 20. So this is your TH. So this is your TH, and then you have 128 pergi 80 and 180 pergi for 20. Okay, so feasible ke tak feasible? Feasible Okay, so because it's feasible, kita perlu buat path tak? Tak perlu dah kan? So basically, remember path tu kita buat hanya untuk correct kita punya delta T mean violation. So kalau dia punya graph tu tak feasible, dia punya heat exchange tu tak feasible, then you have to do path. Tapi sebab dia feasible, you don't have to do path and this is your final answer. So kita punya final answer kita akan dapat 1, 2, 3, 4, 5. So daripada 7 heat exchanges, it becomes 5. Okay, you reduce 2 heat exchanges, kita dapat buang. And your path, but you see what happens is it will increase your utilities. So dia akan tambah sikit lah utility yang kita perlukan untuk take up the load daripada heat exchanger yang ada tadi. So basically kita dapatlah optimize ataupun reduce cost dekat situ. Okay, so basically daripada situ we can see that loop breaking and path relaxation boleh reduce number of heat exchanger units, and you would have some because they reduce number of heat exchanger units, you would have some increase in utilities to balance out the load. And that's why it's also a degree of freedom lah supaya kita boleh optimize HEN. So kalau kita tengok if you try a different loop or a different path, you can see lah you punya answer, but you should end up with basically 4, 1, 2, 3, 4, 5 heat exchangers yang ada kat sini. So any questions for this particular subtopic?
For now, no, Doktor.
For now, no. Crystal clear semua?
Crystal clear.
Alhamdulillah, fantastic. So again, we usually bila kita tengok soalan dia akan easy, but actually if you ask me, this topic is quite easy lah sebab dia fairly straightforward. So if you follow the steps, then you should be fine lah. Sorry, dah ada gangguan dekat sini. So basically, if you follow the steps, then you should be fine lah. Okay, so if there's no more questions, I guess that's all for today's class. I will later upload the tutorial questions for you guys to try it out yourself lah. So you should be able to start to do the questions similar to what we've learned today. So if there's nothing else from me, let's end up the class with Tasbih Kafarah and Surah Al-Nas.
Thank you, Doctor. Thank you, baby.
You're welcome. Itulah, sorry ada gangguan.
Thank you, Doktor.
Thank you, Doktor.
You're welcome.